Okay, this question is, I think, from exercise 9K. I think it's number one. What we're asked to do is we're given two planes, and we're asked to find the equation of the line of intersection. So, um, either way, we have to do a couple of things. We have to find a point that exists on both of these. And then once we've done that, we have to find a direction vector. Now, I'm going to kind of show you two different ways of getting that direction vector, but the way to get the point is the same no matter what we have to do. So let's go ahead and try this. So my preferred way of solving this is going to be to write these as a system of equations. Well, I've got 3x plus y minus 2z's is negative 1. And I've got x minus 4y plus 2z equals 3. Now, if you notice, if I add these together, my z goes away. Okay? And that's exactly what we are going to do and what we are after here. If I add these, I get 4x minus 3y is equal to 2. All right? As I said, now I just need to find a point that's on this plane. Now, no matter what, we have to find at least one point that's on the plane because we're trying to find a line. So we need a point that is shared by these two planes, okay? So to do that, I'm going to call this finding point A. And to do that, all I'm going to do is I'm going to substitute some value in. So let's be intelligent about this. And if I let y equal 2, then when I substitute in, I get 4x minus 3 times 2 is going to be 2. All right. Well, 3 times, so that's going to be 4x minus 6 equals 2. So 4x's has to be 8. So x is 2. So that gives me 2 of the 3 components of this point. Now I'm just going to pick one of the equations. It doesn't matter which ones. For grins, let's use the top one. So if I do 3 times 2, I'm using this 2, plus 2, and again, that's coming from here, minus 2z's is going to be negative 1. All right, well, 3 times 2 is 6. 6 plus 2 is going to give me 8. And 8 minus 2z equals negative 1. So negative 2z equals negative 9. Z is 9 halves. So my first point, point A, is going to be the point 2, 2, 9 halves. Not exactly beautiful, but we can do that. Now, the first way I'm going to show you to get the direction vector is going to be just to find another point that's on the line, and then we'll find the vector between those 2 points. So let's do that. So point B, what would happen if we let's go ahead and let y equal 4. Again, I'm choosing even numbers because this is an odd number and just the numbers will look nicer for part of this. So if I let y equal 4, heck, never mind, I'm going to use 0. So if y is 0, then 4x plus or minus 3 times 0 is 2. Well, then I get 4x equals 2, so x has to be 1/2. And then again, I'm just going to use one of the equations. This time I'll use this one. Doesn't matter which one you use. And I get 1/2 minus 4 times 0 plus 2z's has to be 3. So 2z's is equal to, well, 3 minus 1/2 is 5/2. So z has to be 5/4. Again, not beautiful, but we can make that work. So that would give me the point 1/2, 0, and 5/4. And then to find, now I just need to find the vector that goes from A to B or from B to A. It really doesn't matter. And that's just going to be 1/2 minus 2. This is where my 1/2's coming from. This is where my 2's coming from. And 0 minus 2. And 5/4 minus 9/2. And if I solve that, I would result in, well, -3/2, -2, and that'd be 18/4, so -13/4. My God, it's like I made this problem instead of the book. All right, so that's my direction vector. Now, to find the equation of my line, it's just going to be x, y, z is the exact same as, we can pick either point. I'm going to use A for this, 2, 2, and 9/2, plus lambda times my direction vector, -3/2, -2, -13/4. So that's part A of this problem. Now, this is option 1 for direction vector. Now, the second way of finding my direction vector just takes a little bit of thought, and we should be able to see how this works. So if I have a plane that looks like that, and then I have another plane, and they're intersecting with each other, like on here, well, real quick, the normal to the blue plane, let me do that in the color of blue, is going to be going opposite direction up, something like that, right? Let me just, sorry, I can't get rid of that. So the normal to my blue plane is going to be going up something like that, right? And the normal to my red plane is going to be going something like that. This line here, so again, just so we're sure, this is normal 1, this is normal 2, and this is the cross product of them. So the other way of finding that direction vector is AB is going to be the cross product of the normals of the two vectors. So for that, I just need to grab these again. So the first normal is 3, 1, -2. Sorry. It's going to be 3, 1, -2. And I would cross that with the second one, which is 1, -4, and 2. Now, I'm not going to go through the cross product right now, so let me just grab my calculator. Let's do the cross product. Yes, you would do this with the actual thing, but so the cross product of, I just need to be able to see it, 3, 1, -2, jerk, 3, 1, negative 2, comma, the and 1, 4, 1, negative 4, 2. So I get negative 6, negative 8, negative 13. So I would get negative 6, negative 8, negative 13. Okay, so that is what AB is. Now, I'm hearing you question, but wait a second, that's not what we got the first time. Remember, what we're after is the direction. So long as the first one we got is a multiple of the second one we got, then those two are, as a direction vector, they're the exact same. Very quickly, I've got 13, I have negative 13. What happens if I multiply all of these by 4? Well, that becomes negative 6, this becomes negative 8, and this becomes negative 13. They are multiples of each other. So that is the other way of doing this. Now, you'll still, if you use this method here, you're still going to have to go through and find at least one point just by doing that substitution. So you eliminate one of the variables, then you substitute, and you find a point that's on the thing that crosses them. And that will be exactly what we have to do. Now we have to find the angle between the two planes. Well, the angle between two planes is always going to be the arc cosine of the absolute value of the dot product of the two normals divided by the magnitude of one normal times the magnitude of the second normal. So again, I'm going to, just to save myself some time, I've got my normals there, so I'm just going to copy and paste. Actually, I'm just going to drag it over. Okay. So using these two here, we can totally do that. So the dot product, I need the absolute value of 3 times 1 plus 1 times negative 4 plus negative 2 times 2. And then that's going to be over the square root of 3 squared plus 1 squared plus 2 squared times 1 squared plus 4 squared plus 2 squared. Again, I don't worry about the negative signs because the negative signs actually don't matter, right? When we square it, they all go away. And that would lead to, well, that's 3 minus 4 minus 4. So that'd be 5 over, so this would be 9 plus 1 plus 4, the square root of 14 times 1 and 16 and 4, square root of 21. And realistically, if you're asked to find the angle, unless it is going to be some obvious value, we would just plug that into our calculator right now. But let's see, 14 times 21, 14 is 2 times 7 times 3. So that'd be 7 square roots of 6. I don't recognize that as one of my known values. Like if it was 2 over root 3, so if it was root 3 over 2 or something like that, then we might be able to do something with this. So this is telling me that this is actually a calculator question. So we just need to go back to our calculator and find that value. So from my calculator, I don't know why it loves to expand like that since the new update, but that is really annoying. So it's 5 divided by 7 root 6, I think is what it was. And enter. Of course, thank you. Yes, that's exactly what I wanted you to do, is I wanted you to turn that into that. Oh my God. Enter, Control C, Control V. Thank you. Yes, awesome. Very helpful. All right, so that gives me about 1.27 radians. If I do answer and I go radians, sorry, or about 73 degrees. All right, I hope that is helpful.